Everyone, if you're just watching this, please check the comments for time codes so you can skip around. We're going to take a few minutes here to get going. I was a smidge late, having some Wi-Fi issues in the house. So I'm wired in, I should be okay, but may need to poke the Wi-Fi if it's not working. My partner is upstairs on the Wi-Fi, so she's having some troubles with that, so that's why I have my network pane open here. Looks like we're going. I have YouTube, but I don't think I have Restream open. It must be working. I'll say hi in just a second, folks. Let me get this going too. Salut, Dexter. Okay. All right, let's see. Audio is good, video is good, cat is good. Yep, cat is good. He's actually back in his bed. It's actually starting to get warm enough here that it's like, should I have the window open? Should I not have the window open? And for those of you who keep track, I've got ice in my glass too. So hopefully, I was on the Python language summit earlier this week and the camera actually stopped because it was too hot. So it didn't happen at all last summer, so it should be okay. Let's see who we have in Discord. We have Dylan, Doctor, Dexter, Love the Factory, Fede2, Hugo, DCD, and DCD, thank you for taking notes. Hello, Mr. Certainly. And thanks for relaying to latency seems high. I think I said it. I think I'm on the same setting as usual. Yeah, I'm on low latency, so sorry if the latency's a bit worse. I'm not going to mess with it. If you can hear me and see me, it's totally okay. Live on Twitch. Thank you, Mr. Certainly. Hi, Johnny. Hello, Unexpected Maker. Hello, Beatograph. Hi, Dave, if I haven't said hi to you. Hey, Timonsku. Hi, Bruce. Hi, Paul. Thanks for hanging out. I opened my window and turned on the exhaust fan. Yeah, so if you hear the background noise, I do have I have a fan over in the corner trying to make it a little cooler in here, but I have shorts on as well. Hi, TJ Berlin. 8 seconds of real time. I could turn it on lower. Johnny got their vaccination on Wednesday. Congrats. I get my second dose on Monday, and I'm super excited. And howdy, John Summers. Okay, let me do housekeeping. I feel like this is a little lower than it normally is. Sorry. I realize some people have theirs like underneath them. Second shot in 6 weeks. Hi, Interweb Fiend and David Buchanan. Never go back to pants until winter. Yeah, I'm getting there. I just did laundry today too. Hi, Carlos. Okay, so hello everyone. My name is Scott. I go by TanNewt online, and I work for Adafruit on CircuitPython. Those are two things you may not know, so let me cover them both. Adafruit is an open source hardware and software company based out of New York City, but I work remotely for them, so I am in Seattle. So that's why I tend to say Pacific time, because that's my time zone. Yes, that's Adafruit. CircuitPython is an open source version of Python designed for microcontrollers, which are these little tiny computers. Come on. Switch. Little tiny computers. This one has a SAMD21. This is very tiny. It has 32 kilobytes of RAM, but they're very inexpensive and they're great to start with. So CircuitPython brings the Python language that folks may know from Linux or whatever from their real OS down to tiny computers to do sorts of things. So let's see. This is, if you want to chat with me and a lot of other people, I recommend joining the Discord. If you're in the YouTube chat or the Twitch chat, like those are kind of ephemeral. So I recommend everybody join the Twitch chat, which is, not the Twitch chat, the Discord chat, because it's around all the time. So you can do that by going to the URL adafru.it/discord. That's the gray box here as well. Hello, Andrew Reed. Thanks for joining. Hello, Jose David. So yeah, this is a deep dive. It happens every week, unless I'm taking a week off, which I have a feeling I will in the summer, to be able to go on vacation. It's normally Fridays at 2 p.m. Pacific, but it occasionally shifts to Thursday at 2 p.m. If I'm just going to take Friday off, I'll do that. Next week is on Friday as well. I get my second vaccination next week, and then it's 2 weeks after that I'll be fully vaccinated. So expect after I'm fully vaccinated to be when I start doing more vacation and stuff. So that should be good. Typically it goes for 2 hours or more, and if you have questions, go ahead and ask them in the chats. I do check both the YouTube and the Discord, and folks can see those on the thing as well. Hello. Unexpected Maker gets their first dose May 29th. That's awesome. Hello, Ismail. Hello, Yaron and Sadie, and Xenia as well. Hi, John Franco. What's up? Yeah, so that's what this is. If you have questions, I'll try my best to answer them. And last on the housekeeping is that the kitty here is Spook. He is epileptic. He does have seizures from time to time, but it's rare. So if I'm just headphones off and not paying attention, just sit tight and we'll, no more Git diffs. Oh yeah, I should even say that. But yeah, so if I'm, just sit tight if I'm not talking to the stream, I'll get back to doing that. And I might need to help with Wi-Fi issues too. We'll see. Hopefully not. And then, yeah, I said about next week. So lots to talk about today, I guess. I didn't realize it, but I guess there's lots of different topics. The weeds that we'll get into if we have time is the status LED updates I did are mostly working, but on the SAMD platforms, they were having some problems. So I'll cover that if I get to it. But first, I want to do a bit of, first I should say Micropython 1.15 has been merged in. So it's not in the plans, so sorry, David, but let's talk about this first. So those of you who have been following along, CircuitPython was at 1.9.4-ish. And now we're up to date with Micropython, and I haven't checked today. Let me switch. We can see how many. So we're 116 commits behind Micropython now, which is amazing, because before this all started, we were over 2,000 away. So that was really good. I did have a meeting. I met with Damien and Jim on Monday, and we had some discussion about like, hey, like this is a very rare time for us to be this close, and like what should we want to do, and we kind of like settled on this idea that what our first goal should be is just to make us have fewer differences just in the Pi directory, which is the directory that includes like all of the VM sorts of stuff. So the stuff that actually runs Python is all in that directory. So that's kind of our hope. But yeah, so that's cool, and that was great. Thanks to those folks, those two, for hanging out, and we're gonna keep in closer touch too. I even offered them to come on the show, so hopefully it's like Sunday morning. Unexpected Maker can confirm, but in Australia it's like Sunday morning right now, and kind of early. So I offered that up to them as well. Yeah. Love the Factory says, planned for the 48 hours after shot 2 to not have to do anything. Yeah, I work from home. Yep, merge complete. Hello, Wheeling Wizard from a Pittsburgh suburb. Tomorrow is 8box 18 day. Saturday morning. It's not Sunday, it's Saturday. It's not that far ahead. Big headache for 30 plus hours after my second dose and lots of being sleepy, says Piatograph. I'll let you know. I didn't have any symptoms for my first Pfizer dose, so yeah, so that's where we are on the merge side of things. So I'm basically done with it. I don't think there are any large bugs that we have to track down. Dan also has started a 6.3x branch, so expect to see a 6.3 stable based on a bunch of stuff that Dan cherry picked out. So thanks to Dan for doing that. It's largely just new board definitions because the 7 main branch is like pretty unstable still. And I do want to get this LED blinking stuff in, which is the last thing that's kind of on my radar as well. Yeah, I had a sore arm after my first shot, but that was okay. I just couldn't like sleep on that side. So it's fine. Hello, Minnesota Mentat. Don't worry, we've got plenty of time to hang out, even though we started a little bit late too, so you're fine. We're just chatting. But yeah, Micropython 15 merges is in. I know it's kind of late in Europe, so let me show off. So Timon, who I'm probably mispronouncing still, even though I've met them. Let me answer this question first, and then we'll go on to Piunora. So TJ Berlin says, does that mean that you can now get back to BLE, Scott? And there might be a chance to have ESP32 CircuitPython support sometime not too far in the future. Yeah, so my goal, depending on how the second shot goes, so next week is going to be like meetings, shot, and then I'll have a lot of time, but how effective I can work next week depends on how I react to the shot. Now, my sister and my parents, like, they didn't have any problem with their second dose, so I'm kind of hoping that I don't either. Generally, like, I don't have allergies and things, so I'm kind of expecting it to be no big deal. But yeah, my goal is to get back to the BLE workflow stuff next week. And I should say that I also did, Trevor and I met with Antonio on Wednesday. Antonio is a contractor person that we work with on occasionally on a need basis, right? Antonio does web development for both Android and iOS. So we were talking about collabing with Antonio on building a library for the BLE file transfer stuff. So I met with Antonio, got that plan going, and that should do the tougher bits of the app side of things. And I got Antonio all set up with the CircuitPython demo that I had. So we should be able to get going on the BLE workflow stuff. I fully need to get back to it. I just feel like this LED thing is looming over me because I want to figure out. Well, the LED stuff I want to get in for 7 because it's an interface change. I'm so close, but it's so annoying. And Johnny says also, how about native CP on the Raspberry Pi? It's crossed my mind, but if you've looked in the notes sock, you'll notice I'm actually like quite busy doing some other stuff that's not hardware related, which I think my brain kind of likes to do it. My brain likes to do it because it's very different than the embedded work that I do for my job. But let's talk about that. So, overhead time. Well, bam, and let me flip it. And then I don't think my address is on here. So for those of you who don't know, Timon and I feel like the emphasis I say it is wrong. I'm sorry in advance. We met at SuperCon, and SuperCon was like fall of 2019 now. We had yes, it did come in a box, but I got rid of the box because the box has my address on it. So we had a discussion about whether there was this middle world between Raspberry Pi Linux and CircuitPython land, and I was arguing that like it would be cool it would be cool to see that like that gap get narrower. And one of the things that was interesting was this idea of putting a Raspberry Pi in a form factor that a microcontroller typically comes in, particularly a Metro. So when the I don't know if the Pi 4 were the Pi 4 compute modules out yet. I don't necessarily know if they were, but they did come out, and that was a perfect opportunity to do that. So Timon took this idea and ran with it. So I had some hand in like the discussion for it, but Timon deserves all the credit to making something actually happen. I think it's important to recognize that like there are so many ideas, it's execution that sets people apart. It's not the ideas themselves. It's a matter of like who can actually execute or not on an idea. Yeah, we'll get there. We'll circle back to the ESP. Compute 4 was the last year. Yeah, so what were we talking about? Maybe it was just something that we had. Yeah, so Timon's done this awesome work in conjunction with Crowd Supply, so I want to shout out the Crowd Supply folks as well. They're an open hardware company, crowdfunding company, I guess. Think of it as kind of like Kickstarter, but they're experts in hardware. So Crowd Supply, shout out to them. They're in Portland, and that's what Piunora is being done through. So I haven't actually opened this yet. I just got it today. Right. Someone says in the chat, you were 100% the inspiration for all this. Thank you. I'm happy, and I'm extra happy that you did all of the work to make it a physical thing. It's like, ideas are cheap, execution is hard. So thank you again for really making this a thing. I'm super excited, and I will at some point get CircuitPython running on this. It's a matter of time, not a matter of if. So inside the bag, there's another bag, and I did ask Timon if I could show this off too. Unfortunately, the campaign is actually finished. So if you want to pick one up, yeah. Oh, yeah, David. So I should say there are beta units that Timon has sent out to a few people, and originally he asked me if I wanted one, and I said, well, you know, I have so many dev boards, I don't know when I'll be able to get to it. Like, if there's other people that you should get it to, then that's totally cool. I had already signed up for the campaign. And Timon says you can still order. So if you want this, I think you'll just get it later than the first batch. Yeah. That's one cool thing about Crowd Supply is that like you don't miss it when it's done. They carry it later as well. Awesome. Yeah, so let me just, it looks like there's a bunch of tape here. So I'll just use scissors to do that and go on the floor. Gotta remember that. Sorry, my desk is a mess. I have like a dozen boards here. So let's see what we've got. Oh, look at that beautiful silk screen. There's a 1 in here. I'm not sure what the 1 is for. And yeah, if folks have questions, feel free to drop them in the chat. Timon's in the chat and can answer any questions you have. There's this flat-flex cable, which is a same-sided flat-flex cable. I think it's just because I was reading the beta page. It's because the normal flat-flex cable for the Raspberry Pi cameras are usually like one side on each side. So that's why there's a bit different. Looks like there's feet, which I could put on right now, or I'll just leave it as is, because unfortunately I'm not gonna actually play with this immediately. I really dislike getting Raspberry Pis going, so I'm just gonna show it off. So that's beautiful silk screen. Looks like it's like a dark matte finish. And then I did grab the number is for me to discern the units. I made photos of every preview unit. Does that mean I got the first one? I got serial number 1. That's pretty awesome. I feel special for that. I should put that. I like the logo. I think Bleep Track did the logo, right? Kudos to them for that design. So that's one side, and I do have the modules, so we'll pop a module on just to see. So what do we have here? So it's a So what do we have here? So what we have is we have the Arduino header, and then we have, it looks like an off button, a micro SD card slot. I think this is the ADC, so yeah, that would make sense. So the Raspberry Pi compute module doesn't have analog ADC pins on it, so what Timon did was add an extra chip to do it, which is really neat. And then these two DF40 connectors, they're Hiroshi connectors. Those are for the compute module, which sits in here. And then, sorry, I'm trying to watch the chat while I do this. Yeah, the baud wire here on the preview, I think, is a confusion between the enable pin for the ADC and between the neopixel pin, something like that. I don't remember if it was gonna. I don't think it was gonna be a CM3. Maybe it was just an idea, or maybe it was just like CircuitPython on it. So we've got USB-C, USB-A, and then HDMI. And HDMI is the thing that's really exciting to me. I think this the USB-A is for host, and then the Type-C is what you would treat like a regular Micropython drive. And then there's looks like a Stemma QT if you're in Adafruit land, or a quick connector there. Oh, and this is a slide switch for device or host for the USB side, and there's a neopixel in between there as well. And this says hold for power up during USB boot as well. So that's for if you have an eMMC module. And then here's the back, and I'll stop holding it so it can focus. QC passed, which is good. There's an M2 slot here, and I know that Timon's experimented with different stuff there. And I think, yeah, let me look at that. Nice pinout labels. Look at that, labels the pins, and a camera connector. And maybe one of these is the USB. I think there's a USB chip on here as well for the host. Maybe not. Yeah, so that's a tour of the board. Yeah, M2 PCIe. The crowd supply page, they do show it with some Adafruit modules. Love Stemma QT. Let's see. John says, that's good. ADC is really needed for some sensors I use. Timon says, I mixed up the pinouts, noticed a day too late. John likes the logo too, very clean looking, and like the port option's nice. Asks, any plans for one with NVMe support? The USB mux is top right close to the USB connectors. And it supports NVMe SSDs. That's amazing. And I did get the unit number 1. That is very cool. I'm going to put it on there. I'm not going to cover the logo though because I like the logo. So let's find a spot for it. Maybe right here. I can fit it without covering any of the text. You can do B plus M key NVMe SSDs. Yeah, so I feel a little bit bad because, as you know, I have lots of stuff I'm doing. But this is something that's been kind of in the back of my mind that I do want to do. So I'll get there. I have the compute module as well. So or add the I/O board too. So let's just take a look at what it looks like with a compute module on it. And they use all the same packaging, so I'm not sure what compute modules I've got here. I don't have to put the number on, but I wouldn't know. I would just throw it away or lose it. But by putting it on, I know I can claim that I have the first one. There's no native SATA support, right? I don't know. I wanted to put the number on because I got number 1. Okay, so we must line up the holes here. So there's a hole here and a hole here, and the connector here is not the same way through, and that's true there as well. Like it's closer one side than the other, so I'm just gonna do that, and I'm gonna pull it up because I want to make sure. And these connectors are a little dainty. Fun fact, I use these connectors on the drone stuff I was doing. Okay, so that looks right. Want to know, can I use Arduino Uno instead of ATmega 32U for making my own duck? You can't plug it in the wrong way. It's physically impossible. Really? Oh, because it would hit the ports, right? I don't know much about Arduinos, and I don't know what you mean by making a duck. Fede2 asks, what would be the first step to getting CircuitPython on the Pi 4? The UF2 bootloader? No, I think the first step that's on my mind is getting TinyUSB support going. So get the examples of the TinyUSB stuff going by just like building something and then putting it on those SD card and booting it. Just get the TinyUSB demos going. Yeah, it would collide with the connectors the wrong way around. Cool. And look at how compact that is. And I don't see that I have any shields for the Metro on my desk. But that's the idea, is you could use shields. You could also use stemma stuff, which I think is probably more likely. I don't know what a Wi-Fi duck is, so if other folks do know SATA. And a HID application that writes bad stuff to your computer while you're not looking. Well, the Arduino Uno cannot do Wi-Fi, so if you want Wi-Fi, you're going to need something else. Yeah, so the first step to getting CircuitPython, I think, is actually getting TinyUSB support. And the USB peripheral in all the Broadcom chips, as far as I know, all of the Broadcom chips and the Raspberry Pis, they all use the same USB peripheral that we actually support in TinyUSB already. So I think the biggest difficulty comes with it's Cortex-A, so that the way that it handles, the way that the Cortex-A does interrupts and stuff is different than what we're used to in Cortex-Ms. There are PCIe to SATA boards in that form factor, though, for around $15 if you want SATA. Isn't the Broadcom chip on the Raspberry Pi a stumbling block without the dock/specs? I don't... It's certainly not as good as some of the Cortex-M stuff, but generally, because it's so popular, people have done a lot of research already on on how to use them. The thing that people really want to hack that's really not documented is the video core, which is actually the proprietary GPU that the chips are built around. They kind of took this custom GPU core for playing video and stuff, and then they tacked some Cortex-A chips Cortex-A cores on the side. And that's kind of like where they're like, oh, we could actually do general purpose stuff on these Cortex-As. There is actually like reasonably good documentation for the peripherals. So if you look for like BCM peripherals, and I think I linked to this, but you can actually find like what you would think of as a data sheet, including like address map and registers, I think registers, DMA, interrupts, SPI, system timer. I thought they had a USB one here as well. But the UART, this is just one of the Raspberry Pi chips. But basically, like, they're like not that poorly documented. And there's like people that have been trying to do, like, there's already people that have done bare metal Raspberry Pi stuff. It's just like, I don't have the background with it. I did just do this tutorial thing and got stuff running. It's just like, I haven't had the time to like generalize it. So ESP32 does not have native USB. So if you're trying to do something malicious with USB, then you'll want an ESP32S2. But be nice. Don't be mean. Be nice. Okay, so that's the Piunora, and I'm gonna get to it at some point. And if folks want to beat me to it, kind of like Timon beat me to actually making the device, I think it would be amazing. Timon, I think, is focusing his effort on Linux support on the device, making the Linux software on here act like CircuitPython, which is still a very cool idea. So yeah, I think that's what's happening with that. And you can find it on CrowdSupply. Who is being mean? Somebody said that Wi-Fi ducks are mean things because they like cause unexpected things to happen on computers. So that's what I was getting at. Nobody was like downright mean. All right. It's hot, isn't it, kitty? Oh, you can't see him. Cat cam. Not sure you're gonna. I might have to adjust it. Oh, you can see. This is what he does during the summer, and those of you, I guess this is summer number 2. But if it gets too hot in here, he was all curled up in his bed, and now he's like sprawled out on the floor. This is the thermometer we have in this office. Is what form the cat is in. All right, well, that's Piunora. Thank you, Timon, for getting me an early one. I do hope that I can get to it at some point, but I've got lots of stuff that's peeling my interest away. The cardboard scratcher looks awesome and been eyeing it for a while. Do your kitties like it? Which cardboard scratcher? Oh, this circle one? Yeah, they like sit up there and scratch on it. I think they do like it. We've got a second one downstairs as well. Okay, what's next on the list? That's cool. And if somebody wants to help with that, that would be amazing. I would love to just have CircuitPython on there. I want to have it in the regular repo. But Blinka is for the Linux-based stuff too. Okay. So PyCon is happening this week. PyCon is the Python US conference. And there was the Language Summit. The Language Summit happens every year. It is it crossed my mind to put a heatsink, a Raspberry Pi heatsink on my camera if we have problems with it getting too hot. So every year there's the Python Language Summit, which is kind of a private summit where most core devs for Python, proper Python, get together and chat. But they also do allow folks who are maintainers of alternate Python implementations to come too, because often what's discussed has to do with like the language itself and changes made to the Python language. So there's some interesting stuff here. So that was Tuesday and Wednesday of this week. It was like 2 4-hour chunks. Wednesday I had like 6 hours of meetings. So I'm kind of like done with meetings for this week. I'm excited for next week to be a bit freer. So here's kind of what the schedule was. On the blog, on the Python blog, you can see recaps of all these stuff. But what I thought I'd do, because it is a private talk, is that there's a lightning talks, and I was one of the pre-selected lightning talks. So I thought I would actually just go over that right now as a way to have it kind of publicly documented, kind of verbatim. What we'll do is we'll do it. Hi, Mark. We'll do it just kind of like I did before. Is like it's a 5-minute talk, but I'll just not. It may take longer here because I've got time. So let me get that going. Oh, and I have 2 going. But I think I actually can. When I practice it, I had recordings of it. So I do have. I can either do it in this view, or maybe I do it in this view so you can see me. But I also have this view. Is that a better view? You can't see the chat. That might be cool. All right, let's just go over this so that we have kind of a recording of it. Mark Olson, I know you're here too. Thank you for hanging out. All right, so thanks for having me at the Language Summit. My name is Scott. I do Adafruit, CircuitPython stuff, and I want to take the time to talk about CPython versus CircuitPython, kind of using that comparison to get at what is core to what Python is for people. So if you don't know, I always do this. If I use the mouse wheel, it goes too far. For those of you who don't know, CircuitPython is a small version of Python for embedded microcontrollers. And we've taken kind of CPython, which is like 29 megabytes-ish when you download it off it, and we get it down to about 650 kilobytes, just in the example that I've used here. But the reality is that we can actually go a lot smaller as well. So how does that influence what we have? And kind of my assertion is that CircuitPython still feels like Python, even though there's a lot missing. So I want to talk about what we don't have in CircuitPython that is available in CPython. So here is all of the built-ins. So this is like dir of the built-ins module. This is a dir. Sorry, I'm following the chat too. This is a dir of the built-ins module, and I use this as a proxy for kind of how much of the core language has been implemented. So kind of what you'll see here is a lot of the built-in types, and then also there's like syntax kind of follows this trend as well. So here's all the CPython ones, and here's the ones from there that we have in CircuitPython. So what you'll see is that we have the vast majority of the built-ins, and this is testament to the great work that the Micropython folks have done, which CircuitPython is based on. They've done a really amazing job of getting that core, what I think of as the core of Python, the syntax and the built-ins to be the same, and that really makes a huge difference. Now the second thing that has to do with it is the modules that are installed by default. So this is a list of all the modules that are on my computer as is. There may be a few that I've kind of slurped in due to pip, but I think generally this is the things that you would get with a fresh install of CPython. And I've also knocked out any modules that start with underscore and things. So these are just the ones that are kind of like public. And here's the ones that we have in CircuitPython. And you can see that we have a lot fewer than what CPython does. So I think it's really interesting to see which individual ones that people have kind of like expected to see, and all of the ones that we don't have. this kind of trend goes one step further as well with built-in modules. So I just picked random as an example, a random example. So this is all of the public APIs on the random module. This is using dir, and this is for CPython. Here's all the ones that you get in CPython, and here's the ones that you get with CircuitPython. So you can see that there's a lot fewer, but these fewer ones are the ones that I think kind of, if you've used random previously, these are largely the ones that people use. So I think that's really interesting to kind of influence or show how you can use a subset of a built-in module as well. And I should say that CircuitPython tries to be a strict subset as well. So we want people to be able to use this limited set of random and then go upstream into CPython, and their code just works. So there's two takeaways I want to have, and this is the first one. The Python feel, I would claim that both CPython and CircuitPython provide, require actually quite a small core. That's a lot of built-ins and a lot of syntax, but not a lot of standard library. And even when we do have standard library, you don't necessarily need everything from that as well. And it's important to note why that matters is that smaller cores mean that Python can be in more places. CircuitPython is a great example of that. Is a great example of that. So it's important for us to think about how we can reduce the barrier to getting Python in more places. And I also want to point out that like smaller not only means that it can go more places, but it can also go places faster. So a smaller binary means a smaller download. So potentially you could see getting Python delivered kind of as needed. However, by being a small core, there are some things that have been left out. Now, some of these things we kind of have alternatives for now, but we may have not had it in the past, and people asked for it. So those things are NumPy, fstrings, pandas, Jupyter, PDB, which is debugging, and async IO. This is by far not an exhaustive list, but it gives you an idea that like actually the things that people bring from their Python experience to CircuitPython are a variety of things. They're syntax things like fstrings, but they're also third-party libraries like NumPy and pandas, workflows like Jupyter and PDB. So it's really a mixed bag, and that's the last thing I want to bring in. The second point I want to make is that Python is actually much bigger than what ships with Python, and what the Python runtime actually is. People associate Python tooling like PyCharm and things like that with Python as well as the packages that can get up PyAPI. So it's important to think that it's okay to think about moving things from the core out into the wider Python ecosystem in order to get things in order to reduce the size of the small core that we can get to more places. So that's it. That was my lightning talk. So let's go back to this. 1600 megabits of pure Swedish internet here, says Johnny. Oh, you're gonna segue right next into the next thing. Any questions about this? I see Fede2 asking, have people asked for something like pip? Micropython has micropip, but a lot of people kind of reach the same conclusion that I reached, which is like having something built in is not that helpful because most boards don't have internet. I think it would be fair to say that people want something like pip because like Nicholas Tollerby started Circup, and then like Patrick and other folks like really ran with it and made Circup really, really cool. So it's it's important to. I think we need a packaging story. I don't necessarily know it's pip, but I think Circup is kind of that, and the data that we're getting for Circup is like being very generally useful in like the project bundles as well. Unexpected Maker says, very cool, but async is in Micropython. I know it's not in CircuitPython yet, but should that be on the last slide? The last slide's not about, and this came up earlier as well, because, so CircuitPython has F strings now too. So the point of the last slide is not to say the things that we were missing, but the things that people have asked for when we missed them. NumPy, we have Microlab as well. So I think it's, don't, that slide's dangerous because that slide gets misinterpreted. Yeah, Circuit. CPython without pip would be very unusable. Yeah. Minnesota Mentat said, would love a brief review of exclusion choice for F strings. I'm not exactly sure what you mean. Yeah. I probably won't give this talk again, so I tried to be clearer when I just said it, but obviously some people still had the wrong conception. Like right after I gave the talk to the Python Language Summit, like Brett Cannon pinged me of like, oh, CircuitPython doesn't have NumPy, and so I replied, I was like, actually, that wasn't my point. My point was this, that people want NumPy, and we have Microlab, which is a subset of NumPy. So, yeah, it's a little confusing. But that's what I meant, right? Like, my point is that, like, and this is the thing that's really hard to do as somebody who leads a project, is like, you kind of want to add the things that people are asking for. If you go out of your way to add something that nobody wants, nobody will use it, and you just wasted a bunch of time. So CircuitPython has F strings. It's implemented as a conversion kind of at parse time into format strings. There were some concerns about that implementation when they proposed it to Micropython. So Micropython does not have F strings yet, but it's on their radar. And those of you who don't know, F strings is a way to put your variable names in line in the it's in line in the string itself. So you do like, I could show you. So here's my Alpha 2 build that I was debugging on. If I just do x equals 1, I can do f, I assume it works here, and then you do curly braces, f of x, and that kind of, it binds immediately. So it's great for printing out debug printing stuff. And you can also format it just like you would. X is kind of confusing because that's a variable name, but you could format in the similar way to like 08D, using the same sort of thing that you would with a oh, you don't see my screen, thank you. Didn't see that. Yeah, thank you, sorry. So this is just CircuitPython X. I did f of curly braces x, and then I printed out a string with the variable in there. The theater of your minds. Yep, and then the second f string. So f strings start with f for format, I guess, but they capture the variable at the time that they're in the code. Whereas if you did something like if you wanted to do it later, you would do something like f equals. Oh, that was weird. It was like a bug a bit. So now I have the string here that hasn't captured it yet, but you can do f format, right, and then x, and now that gives you that. So f strings are about like what is the cleverest way to parse an incoming string in CircuitPython? For say erratic strings from another CircuitPython pushing variables over UART. Ooh, I don't know if I would do it that way. I don't know if I would go. I know how I would do it in CPython. CPython, there's this great library called Parse. Python Parse library. it's really cool. It's the reverse of format. So this is only in CPython. It's not available in regular Python, but you can say like give it the same format string and it gives you the result out. It uses regular expressions under the hood. In CircuitPython, I think the easiest way is like comma separate it and then just do a split and then cast. So if you have like an int coming in, you just do like, let me show. So like say you're getting a string s and it's like 1, 2. If I print that, what I like to do is like s split of comma, right? So now you have two things, and then you could say int of s split and like the 0th thing. Now that gives you an int as 1. Yeah, so like that's kind of like my approach, is just splitting and casting. It's not super clear, I guess, but is it clever? I don't know if it's clever, but I do that a lot. I love Python scripting, as maybe, yeah, I want to talk about as well. Nerodoc says, if you control both ends, I'd use JSON. Yeah, JSON could be quick. When you add something that is not used, it is then taking space out that something could be using and used by the user base. Mark Olson points out message pack, which we do have. Thank you to IoT49, I think is the community member who added message pack. But you could look at message pack as well as a way to transfer data across. Ryan G points out JSON is easy, but it's pretty inefficient. Gareth says, clever programmers try to write straightforward code. Yeah. All right, well, there's some options for you to work with. What's next on my list here? Broadband Map. Should we get away from CircuitPython for a little while before we get into the last debugging stuff? I just looked at the neopixel on this thing and it's not right. Protobuf has become extremely popular. It's got bindings for a ton of languages. Yeah, I like protocol buffers a lot. So let me venture away from CircuitPython and show you kind of what I've been doing outside of work, because I like to do that. So I showed off this while law stuff last week or the week before. And the two merge requests that I had faked here are two different broadband bills in Washington State where I live. And I just wanted to say for this that both of them were signed by the governor, so that means that they're actual law, which is awesome. The second one had one veto that I'm not sure. The governor can veto like individual sections. So yeah, both of these were merged. Both of these were merged. Yes. Unexpected Maker, are you around for the rest of the hour, or do you want me to skip to that because you're curious? I could explain it. Yeah, so I think this is pretty cool. And I actually linked somebody to it earlier today because we were like a little worried. This 5383, I'll just show you. 5383, so these are both about expanding what government agencies can provide broadband service directly to customers. So retail ability. So public utility districts who do like who would do like water, sewer, garbage, electricity, that sort of stuff will be able to now directly sell broadband internet to customers as well, if they're in underserved areas. But I linked to actually, so this shows the revision history of the bill itself. And we were a little worried because this bill originally had a clause that allowed commercial interests to object to it. But it's kind of small. How do I make this a little bit bigger? So what people were worried about is that's just reporting. This bubble here. So the original version of the bill said a port district may provide retail communication services to an end user in an unserved area if the port district receives notice from the governor's statewide broadband office that an existing service provider has not submitted an objection and a broadband service plan required for the subsection for the same project area. So basically, this gives incumbent internet providers the ability to prevent public utility districts and port districts from doing internet in their area if they claim they have a plan to give better service. But at the end of this bill, they actually deleted it all. They replaced it with a port district may provide retail communication services to end users in unserved areas, which is awesome. So they deleted a bunch of the stuff that was like particularly bad. They do still have to provide notice that they're going to do it. But they don't have any veto ability. And they set the minimum. The definition of unserved is 100 megabits down and 20 megabits up, which is larger than, which is better than the federal standard, which is 25 down, 3 up. And then I was looking at this today. There's actually this other, I don't know if it's in this version. So here's what unserved means. And I think I was looking at the changes overall, but there is also a condition here that when they do it, they have to do it as an open access thing. So if they run fiber to somebody's house, they have to, another ISP has to be able to provide the like ISP side of it, which is super cool. Mark asks, how fast is your internet? So I have fiber internet here, so I get just under a gigabit per second both ways, which I love. It's awesome. Yeah, protocol buffers are cool. I'll actually talk about that in just a bit. TinyUSB. Right. Yeah, Fede2 says, specifically for broadband in Costa Rica, we have mostly one bad provider per area instead of the chance to choose a good one, so they're all mediocre. Anyone should be able to give internet anywhere. Yeah, so the reason is that I have sad slow 100 megabit per second symmetrical. So this is a segue to another project that I have that I worked way too much on last weekend. I'm starting this site now called fiberdeserts.net. And what it is it's trying to map in the US where what service everyone has. So it's based on this is using Mapbox, and it's using the FCC as the Federal Communications Commissions or something. The ISPs are required to report at the census block level, which varies widely, and I was trying to get it in this map, but it wasn't working. Trying to report at the census block level what service they provide and like what technology they use to do it. So this looks like a pretty normal map. Those of you may not know that I worked at Google for 6 years on Google Maps, doing kind of rendering stuff like this and styling stuff. So this is kind of like was my jam for a long time. So it's kind of fun to see where the open source world lives. Mr. Certainly says 50-50 at the apartment, 50-25 at home. We could get more, but it'd be 100 plus a month for the increase. 50 down is more than enough for 1 to 2 users. How much, Mr. Certainly, if you don't mind, how much do you pay for 50-50? Did you work on any of the maps plus satellite stuff? No, I didn't do any satellite stuff. I was literally like taking vector data and rendering the map. David Buchanan says, yes, the federal FCC broadband rate is poor, but the big ISPs have a lot of influence on setting it. Hopefully they will be forced to do better at reasonable cost. Yeah. Mr. Certainly says $84 a month for 50-50 from Verizon. See, I'm paying $85 a month from CenturyLink for my gigabit symmetric. Hugo says 500 symmetric for 50 a month from Frontier Fios. Anecdata says my 5 megabits per second DSL is 60 a month. Yeah, Anecdata, if you're in the US, I would check to see if your local, if your state or federal, the federal FCC has a download thing you can do, and Washington State has it as well. But yeah, I would encourage everybody to look at the FCC and do any of their download things. Yeah. Mark has 150.25 for 50-ish in the US. Timon in Germany pays 60 a month. Mark Olson pays 50 US for 250. Oh yeah, so I haven't even shown you the coolest part. So when you zoom in, it actually colors the buildings whether they have fiber or not, or whether we think they should have fiber. So based on, this is projecting kind of the census blocks onto the buildings. So what we have here is we have like this building, we can see that the best person they have is Comcast, and they're doing cable, and Comcast actually can rate higher if I'm doing like the total speed. So one thing that's kind of garbage about this FCC data is that it is the advertised rate. It's not the real rate. And then I also have it tracking whether there's anybody in the area that provides fiber. And if so, who is it? So CenturyLink fiber is here as well. And then if we look at like the black one, we'll see that it's just Comcast. One thing I found, I was looking at this, and this is actually an old version. I need to push a newer version, and maybe I can get it going. So I've been working on this a little more than I should have probably. But the newer version I have is actually also coloring the outsides of the roads green if we think there's fiber there. And by fiber, I mean like potentially business-only fiber. So here you can see that there's no fiber to the home, but there is fiber in the area, because the data says whether it's like consumer or business only. And the reason this is interesting is because generally fiber, like telecommunications cables, are run along the roadway. So see this big, sorry, I need to figure out how to make this inspector work differently, but see this big clump here of all these homes that don't have anything? They're just Comcast. Like, if we wanted to figure out how to get them fiber, you would probably run it along the roadway. So marking these roadways as like, this probably has fiber, would allow us to do this like maps network algorithm of like figuring out the closest place to get this house fiber, for example. Fedit says, what color are the buildings where the NSA sniffs everything? That's all of the colors. Although, to be fair, one of the things that's good about fiber optic cables is that they don't radiate data. Like copper wires will have like magnetic changes outside the cable. So at least fiber, they have to get a little bit more clever about how they intercept it. Could you go around the business consumer by getting a business plan for a home-based business? Potentially. Good night, Dave. Andreas is showing off 13 a month for 300. Yeah, Johnny says, my cable TV ISP offers 1.2 gigabit and gives you a router with 1 gigabit ports. Yeah, I was thinking that would be actually, if I had to pick what I think the minimum rate should be, is the minimum rates should match common Wi-Fi speeds, right? Because most people are going to just plug Wi-Fi into their wired network connection. So I would do it based on like how fast like a Wi-Fi access point is, like Wi-Fi 6 or AC, right? Is like kind of I would pace the minimum broadband requirement to match Wi-Fi speeds is what I would, if I had to pick what the speeds would be. But then that requirement has interesting consequences for like policy, right? So that this map is really interesting from the perspective of in the US there's a lot of money going towards infrastructure, including broadband, and like how that money actually gets spent and whether it ends up like laying fiber is kind of like really important, because that money could be, in my opinion, wasted on like paying for wireless solutions where wireless solutions are not going to be a long-term investment. So one thing I was just browsing this though, and this is kind of neat. So there's a big dam here in Grand Coulee. It's where a lot of our power comes from, I think. But one thing I was just looking through this and it was cool. It's actually, their fiber is actually already provided by a public utility district, which is really neat. And so I looked them up. Grant County PUD. So it's a public utility district, and where did I see it? But they run an open access network. So I forget where they see it. But basically they say like, hey, here's where you can see all the different people that you can buy internet from. But they manage all of the like the physical infrastructure, which is really cool. David says, it will be interesting to see how 5G cell broadband to the home influences the costs. Yeah. I mean, I think that's also the danger is like people may think that 5G is good enough when like it's probably still best to just run fiber everywhere. Like just spend your money on fiber. Doctor says I have a 10G network, want internet to match. And you can get, where they are at least, you can get business at a residence for a registered home business. Yeah, I only have 1 gig Ethernet in this house too, so anything over a gig is not going to be useful. All right. Okay, so that's my like non-project. So if you're interested in this, and yeah, if you're interested in this, let me know. It's kind of just the next thing I want to do is I want to actually overlay the outlines of all of the census districts or census blocks, so that people could actually look stuff up. Because there's also like RDOF. I forget what it stands for, but it's like one of the. There's a lot of money going towards rural broadband, and so there's this. It's Rural Development Fund or something. So there's a lot of money that they've announced for like providing more service to people, and they kind of like say what census blocks those grants will give. So I want to be able to say like for this block, is there any RDOF money going there, and if so, like are they going to spend it on a fixed wireless connection, or are they actually going to not? So yeah, I've been really interested in broadband policy. I think I'm a firm believer that everybody should just have access to low-cost, high-speed internet, and that is an equity issue as well. So this is another way that I can hopefully help with that policy. And it was started from, there's a podcast that I listened to, and the guy kind of said like, it would be really nice to have like a public data source for all of this data. So I was like, oh, I'd like to work on that. So that's what I'm doing. Okay. That's my 4-way. That's the non-hardware debugging I've had to deal with. I only have 1 gig Ethernet, yeah. Internet should be as easily accessed as food and water. I definitely think it should be a utility, but I think food and water are higher priorities. Which podcast? Community networks .org. Yeah. Communitynetworks.org has Connect This. This is the podcast I've been listening to. Which is really interesting. It's folks that like run ISPs. And then they also have broadband bits as well, I think. What is this? Another map. Oh, I could rant a bit about maps. I really, as somebody who worked on maps a long time, I really dislike maps like this. Where they've just like splotched everything on top. And I think you could see that in the way that I've started designing fiber deserts. It's like, it's just kind of terrible. Oh, I think this is out of date. Yeah, this is a restriction. They've lifted that restriction on public utility districts. I don't know what these are. Visit network website. Dark fiber. I will have to take a look at this. This could be kind of cool. Like, I'm looking for all these sorts of like data sources that I can kind of like glom all together. One other one is that at least in Washington State, the broadband office, Washington broadband office, we can talk about terrible maps here too, has speed tests. So you can actually do like a speed test, and you put in your address so that they can tell you where you are, and you can give your contact email. We do not store your personal data or address. So they do store your email, and I actually kind of found the raw data for this. So, and they have emails on it. But you can go here. Oh, nice. Orienteering. So here's the results of that survey. And it's interesting to see like total survey response. And again, this is just like dropping, I think they call these measles, dropping measles on the map. So another thing I'd like to do is I'd like to take all of this data and partition it by those census blocks so that you can be like searching around and find the census block where like some of these bad reports have come from. And you'd be able to say like, these providers claim they have this service, but these people said that they have terrible or no internet available in that block. I want to ingest this data too. I'll strip the emails that are on there because I don't need them. Paul says, in Lisbon, Portugal, I have a fiber connection, 200/100, together with 150 channels of TV, fixed phone, and one mobile phone with 3 gigs data package. I pay 58 euros a month. I forget what euros to USD is. I think it's I only find out when I go to Europe. Let's just look. Euro to USD. $70. Like, that's super good, right? Like, for TV, phone, and a mobile phone, and fiber. Like, I'm paying 85 for fiber alone, although it's faster. David G says, I installed LibreSpeed at home and did run speed tests from various places in my house on various technologies. Should I do a map? Yeah. Well, I think that's one of the things that whenever I'm looking at like speed test data, I'll have to account on being like, that's suspicious. It's suspiciously capped at like what a Wi-Fi connection would cap you at. So I'll have to take that into account. And that's kind of why my philosophy is like the minimums should be in line with Wi-Fi speeds. Because like the reality is that people are going to be on their phones or their laptops. Like Wi-Fi is going to be the way that a lot of people are going to use it. Okay, enough of that. Let's go back to CircuitPython and get our snorkel masks on to dive deep here at the end. But first, we'll cover the broader thing that I'm working on. So, because Unexpected Maker missed it last week, I think. So, let's just show. Unplug my headphones. We got a snorkel emoji from Mr. Certainly. So what I'm doing is I'm changing the status LED to what somebody in this chat a few weeks ago, I think, rightly pointed out, that it's kind of it's a only when you need attention sort of policy. So this is the Feather NRF under here. And I think it is actually running code. Let's shut the server down. This is the other board I have plugged in. It's probably 2. There we go. So the status LED is changing. It used to do, when your code ended, it would do this big, long, complicated, like, here's the file, here's the error, here's the line number sort of pattern. And it would kind of repeatedly do that constantly. And once we did low power, I realized, like, one, that that stuff is like, flashing the line number is just more painful than it is helpful. Because so many people are like, I counted it, what does it mean? It's like, no, just connect to the serial port and you'll get a lot more information. So I wanted to do away with that because it's just, frankly, not helpful. And then what I realized is, like, we should actually be much quieter with the LED because it takes power. And now that we can do low power, we should have this model that's, like, more judicious, like, doesn't blink as much. I've simplified it all. The LED lights up at the start when the safe mode window is happening, and it does a blink pattern there. It's like 700 milliseconds, although Dan had the idea to make it longer. We might make it longer so it's easier to hit. And then there's three patterns you can get after your code is done. Well, 2 patterns after your code's done and 1 for safe mode. So safe mode will be 3 blinks, 3 yellow blinks. This is an exception happened. It's 2 blinks and it's every 5 seconds and it's red. So the color is a nicety. It's not required. So yeah, this is what happens if you get an exception. So it's just enough to hopefully catch your eye so that you can check on it and figure out what's wrong. If I have Control D, now the code is running, and you'll see that the LED is not on at all. It used to be green, but now it's quiet, which is actually, it turned out to have this really nice consequence, is that we don't change the status LED color while code is running now. So it's actually much simpler internally. We just use the LED. We initialize the LED when we're going to use it, and then we de-init it when it's done. Unexpected Maker says, this all only happens when USB is connected right. It's bypassed when running off battery or external power. No. This happens off USB as well, because the assumption is that you would want to know if either your code completed and is no longer running, or whether it errored for some reason. If you're doing sleeps, it won't do anything. But if you're in the state of, like, you thought your code was running but it's not, like, it's still meant to blink. And I did change the code, and this is one of the reasons I was having problems, is the code that flashes, the way it used to work is it used to be this while loop that kind of perpetually set the state of the state of the neopixel every time it went through the loop. So it was like super bad in terms of power. But what this code now does is, what it will do is it will set the state of the neopixel, and then it will sleep. It will light sleep, not deep sleep, but light sleep, until the time to wake up and change the state of the neopixel again. So it's a lot less time, a lot fewer times through the loop as well. So it should actually be, it's not as good as deep sleep would be, but it's a lot better. And it's really meant to be this mode of like something's wrong. Like you should take a look at it. So it's a 5-second gap so that so we save power, but then also we should be able to hopefully catch out of the corner of your eye these 2 blinks. If it successfully completes, it will just be 1 green blink at the same rate. And there's the charging LED here that you can see maybe the flashing of as well. So yeah, it's meant to be simplified. Thank you again to Neradoc for testing this out, because on the NRF it works just fine. But it turned out there was a bug on the atmel-samds, which is what has absorbed a ton of my time and that made me so unhappy with neopixels. Unexpected Maker says, okay, so unless there's an error, CircuitPython doesn't touch the LED, so no additional current draw for code running a sleep-wake cycle. Correct. Yes. It will turn it. It will do the init. If we look at the code, it'll do an init, but then it'll be turned off when you go into deep sleep. So this code is in main. I actually moved it back to main. Oh, I can't see. Let's do this. So we're in run code.py, and here's where the code actually runs. Then this is what happens when it finishes. You do cleanup. You see if you were forced to exit, and then you just return. Otherwise, you go into this kind of wait state. So first we figure out, like, okay, which color are we going to blink and for how long? Get the timing information to start, and then this is where we'll init the status LED. So we will actually initialize it, which I suppose we could prevent. But then in this, so this is the while true loop. This is waiting for you. This is the like press any key to go into the REPL or Control D to start over. This is the loop that's running when that's happening. So there's a bunch of ways you can break out of it. There's this. If a reload was requested by the supervisor, if interrupted by the keyboard, if fake sleeping, then we check the alarms. Checks to see if serial connected if the serial's been connected while it's in this state. If so, print out that that's what it's doing. And then there's kind of this big if here that says, if you exited because you're going to deep sleep, manage, like, we have to wait a little while to give USB a chance to start up, and then either pretend to deep sleep, or wait, I guess we turn the status color off, which I don't think we need, because it should never be on. So the only time it's actually status color is set on is in the else clause of that, which manages like refreshing the display and setting the colors on and off based on timing. And then you can see here that there's actually this idle until interrupt. And there's a bunch of debugging in here because it wasn't working on the SAMDs. Let's see. So on my Feather S2 that has an RGB LED running off LDO2, LDO2 has to be powered on for the RGB LED to work. So if it gets knitted, LDO2 gets turned on even if the user wants it off. We don't have a good story for how we manage onboard power switches. I'm not sure what it'll do on your Feather S2. I don't know how. Aren't we just turning it on forever or something? There is, I think I have board and knit stuff in here as well. They have board init as well, so it could be part of board init. I'm not sure what it'll do. You should check. But like the principle of it is that like in CircuitPython, if the code is done, we don't care what the user wants, right? Like the user code has stopped, therefore the user has no influence over what happens. But that's not entirely true. Like if you're deep sleeping, clearly that influences what happens afterwards. And then also, oh, Randall says flash the blue LED on the Feather S2. Yeah, so all of this code, it does work. It does work with a single LED as well because the flash patterns are different. So that's an option as well. Oh, David says, missed the beginning. What is the recommended CM4 for Piunora's CircuitPython future use? And did you see on Show and Tell that Micha plans to work on CP bare metal on the Pi 4? I didn't actually. I missed Show and Tell. I will watch that after this. Thank you for the link. I missed Show and Tell because I was at the Python Language Summit. LDO2 is user switchable. On a sleep-wake cycle, a user would want the wake time to take as little power as possible before sleeping again to elongate battery life. I mean, yeah, we could refine this. I don't care that much. The main thing I want to do is get the LEDs blinking differently. Timon says, hi, David. I recommend any model that has Wi-Fi. Wi-Fi doesn't really matter because it's unlikely to be supported anytime soon in CircuitPython. But yeah, generally having Wi-Fi would be better for CM4. Yeah, you could set it up to be. I did change it, so if you just don't want to, just don't set the RGB status LED to the pin you have for it. Just set the blue LED and that'll be it. You could do that. It should be just fine. Okay, so where am I at? Well, I'm in terrible, no fun, NeoPixel sucks land. Pardon my French. Or not French. So here I have a Feather M4. It's currently in the REPL, and the NeoPixel's blue, unfortunately. Which, oop. So, the NeoPixel's supposed to be white in the REPL still. The REPL works a little bit differently, but it still should be white. But it's blue instead. And if I hit reset, where's the reset button? It's like right next to the NeoPixel. If I hit reset, wait, was that yellow? No, it's green. So it's supposed to flash yellow, but it flashes green instead, which is just like such a pain. So the Feather M4 is, the timing's correct now. So I found a bug where the SAMD was not sleeping long enough. It was sleeping weird intervals. The autograph says could use just enough Wi-Fi for a second REPL. Wi-Fi is complicated. I don't think it's easy to have just enough. I think if you're gonna get Wi-Fi, you're gonna get all of Wi-Fi. I'm actually more interested in BLE on the Raspberry Pi boards. I love my CP board because they have onboard flash, and I don't want to find a micro SD card every time I want to use them. Yeah, I mean, they have eMMC ones. So here's a capture I did earlier of NeoPixels. NeoPixels are, these ones in particular are going to be a huge pain. So I actually have some other boards I want to try as well, like boards on my desk here. I haven't tested the SAMD 20 ones yet, and I've only had a problem with the NeoPixel on this Feather M4. So I want to find, I think I have other M4s here. I just want to try those as well. And actually, if anybody has a Feather M4 handy and is on Discord, I wouldn't mind sending you. It would be nice to send you a UF2 just to see if it works in the last 30 minutes that we have here. So I've actually played around with this timing a lot. And based on my understanding, this is actually a bit slow timing, but it should be perfectly valid. Even if I have a thing on here that should capture it correctly, but I basically like, so this is the analog trace. Here's Christian says, is the res LED just burnt out? Just got here, so not sure. Oh, for the yellow? I suppose it's possible. I suppose it's possible that the red element of the neopixel just doesn't work. Because I've seen it. Is that true? Actually, that could totally be possible. Actually, that would make a lot of sense because the interesting. Yeah, Christian, I think you're right. If red is dead, yellow will be green and white will be cyan. Holy moly, I think you're right because the bootloader, which does work green, if I turn off data, so I just flip my switch off screen here. If I double click it again, see what the red LED is doing? It's ramping up and down to show that USB is connected, but there's also a state where it's fast, but now it's off. I think that could be it. I think you're right. Okay, let's just confirm. So some folks have some, but it's not a reflow because it's like clearly the chip itself is connected. But yeah, I think you're right. M4 can. Yeah, tell me what SAMD51 board you have, and I'll drop some builds in Discord. And we can have folks confirm that it actually does work. I've been messing with it a lot, so I should actually get it probably back within timing. But we could do that in the next 30 minutes. That's easy. But yeah, that would make... I didn't think about that. That the hardware is actually broken. I don't know why it's so slow, though. So, let me just build a new one. Yeah, maybe I could actually see it. Because there's usually, like, the bond wires, right? It's possible, like, the bond wire is broken. Alright, so I'm going to jump, build... Ooh, my AirTag was delivered. Kind of hard to fix that hardware issue in software. Well, I was trying to. Okay, let me... Feather M4... Alright, so if you want to try that out, that's in the live chat Discord. Oh, reflow to change the LED. Drop to REPL and set it to red. That's way more work than I want to do. I think that actually makes a lot of sense because I did try it. So I had this this Metro M4. And it's working, I think. It was working. So I think I just messed with the timing a little bit more than I should have. But yeah, see this Metro M4, which has code I put on today, is working. So yeah, I think it would make a lot of sense that that Feather M4 actually has just a busted LED. Yay, more work. So let me just get these timings. I want to get these timings kind of back to what they should be. So the thing that I was going for is add to the test environment to cycle. Well, I think it worked previously. I don't think it's been broken forever. I think it's just like all these boards are old and I don't treat them well. So it's not. It wouldn't surprise me that it was like an issue from just my environment being on my desk. Okay, so one thing I want to do is I want to get rid of this gap. So let me show. I actually changed this code. So CircuitPython. So the SAMD code, and we need to check the M0. Common HAL, neopixel right. Lots of M4s, but no feather. Just see if you get red. So load that UF2, and then if it should blink yellow on startup for safe mode. And if red doesn't work, then it'll be green. And then if you just put like a raise runtime error. Jose David says the neopixel is not working. Mark says mine is blinking red. Okay, good. This is good. So these numbers I think are a bit out of spec. So there's this really weird thing, and I looked, and Jeff is the person that added it. So this is the neopixel core code, and I'll make it a little bit bigger. So it's actually assembly code. Yeah, 2 red blinks. Static or over voltage could just kill red since it has a lower forward voltage, but that's just speculation. It would be unusual for the neopixel to lose a channel, not just die, though. I mean, it works on the Metro, though. So this reminded me a lot of my PIO programming. So there's, and this code comes from the UF2 bootloader. And one thing that jumped out at me when I was looking at this is there's these if-defs for SAMD21 and SAMD51, and the delays are the same. It says delay 6, delay 6, and I was like, and 6 here and 6 here, and I was like, that's weird, right? They're clocked at different rates. SAMD21's 48 megahertz, and the SAMD51 is 120 megahertz. It's like, how is that weird? Like, how is this code even working? Because the clock rates should be different, and yet the delays are the same. So that was really weird to me. And so what I looked down here is that there's this big long thing, but it's interesting. When this routine is positioned at certain addresses, the timing logic below can be too fast by about 2.5%, or 2.5 times, which, you know what? 120 divided by 48 is about 2.5. Right? It's like about 2.5. So when Jeff went in this code before, I think he debugged this issue as the timings were wrong. It's not his fault, though, because the UF2 bootloader doesn't run the SAMD51 at 120. It just leaves it at 48, which is what it starts up as. So in CircuitPython, we take that 48 and we boost it to 120. But in the bootloader, we don't bother because 48 is plenty fast. And that's what you need for USB. So there's this cache changing stuff for NeoPixel for the SAMD51 that's basically like reducing all the caches between the flash. And the flash must be slower. The flash might be clocked at 48. And by removing all the caches in front of the flash, what this code is doing is it's effectively running all of this assembly code off the flash at 48 megahertz. I'm not sure the Feather M4 can has the same pinout. I can build you a M4 can if you want to try it. Jose David. Was it just M4 can? Yeah. They're just all going to be called firmware UF2s, so maybe like keep track in the chat which one's for which. Yeah, so I thought this was really weird that it had to do all this cache stuff, because I realized like, oh, the reason it's doing that is because the clock rate's different. So what I have here is, in my version, I've taken all that cache stuff out. And then what I've been doing is I've been messing with these delay numbers to try to get the timing right based on the Salea captures. So I've done this a number of times now, but the last time I did it was for the RP2040, and the PIO makes it really nice because it's exactly changing code like this to be like cycle accurate. So I started changing this to make things different, but if the red is just broken on my NeoPixel, I got it back to, like, when I asked Phil B about this, it was basically like, shoot for 800 kilohertz overall and do a third, 2/3. Let me grab that build for, let's say. Okay, so this one is the CAN build. CAN. And if other folks want to try, let me know. But I'm going to change the version here in just a bit. So I undid some of the timings, and I'm just going to do it on the Metro because I trust the Metro. So I just did it back, and let's see where we are at. So I'm going to make myself a Metro build, and I'm going to clean to make sure I'm exactly on what I want. I love this fast computer. Just be like, oh, I'll just clean it. It's fine. All right, I'm going to flip USB on. But yeah, that would make sense. It just doesn't work. So I'm going to double click. And I'm in the bootloader. Oh, you know what? Let me unplug this feather. If you want to test red, you can try CB code to turn the neopixel red. But there's other code that's trying to trigger red. That's running. And I was like Saleaing on the lead of the neopixel, so I know that like the data is getting there. Yeah, 2 yellow and then 2 red repeating. That's right. So you should get some yellows at startup. Thank you, Dexter. You should get some yellows at startup. That's when you can press reset to get into safe mode. And then you should get 2 reds repeating if your code is crashing for any reason. So Metro. So I just want to adjust this code back to. I see the yellows at startup too. Mark, you see the yellows, but you don't see any reds. It's possible your code is running, depending on what you have on there. If your code's running, you won't see any blinks out. You won't see any other blinks. So like get in the REPL and like, or get in the serial. I'm using Arch Linux for my OS. Jose David's not seeing anything. Let me... How's this one doing? So it's still working. I actually want to do a Salea capture, and hopefully this computer can handle it. So I'm actually going to do it straight off the leg. And I think it's the... I forget which one. It's off pin 1. Sorry if I end up with my head under the camera. Okay, so I may do a capture. Welcome to the world of NeoPixel timing tuning. All right, so there's one. I should take a capture like this on a 6.2 board because you'll see that like the white NeoPixel in the REPL is correct. Red is after a code.py error that dropped you to the REPL. It won't drop. The REPL should be white, but if you're in that intermediate state where it's done, it should be red. Okay, so let's see how close we are on timing. So here we can see that we have the blink, 1, 2, 1, 2. So on, off, on, off. This is off, so that's not going to be that interesting. But this on will be. So it looks like we're a smidge fast. So I'm looking at the frequency is 968 and the duty cycle is 40%. And then I was experimenting with going faster. I had it spot on earlier, so can I just undo it some more? What does my undo history have? I don't think it has anything else. That's a bummer. It being too fast means that these numbers are too low. So let's just mess with them by making them a bit higher. So let's leave. So, okay, what numbers do we have here to play with? We have this delay. This is after it's set high. So this is there's always the pulse always starts high. So this is the first high period, and then there's this branch not equal, and it skips there's two clears when it goes down. If it's not equal, it does the second one. So this second delay here is the middle third of the pulse, and then there's the final third, which is here. There's two places the final third is. It's either here or it's here. This delay here is the ending delay if you're loading a new byte of the neopixel. So we have 4 numbers to adjust, and I just want to try to do the like. Let's see what Mark has got. Oh, it's so meta. Yeah, that looks correct. Yep. Yeah, that looks right, Mark. So I just want to, I want to tune this back to what it should be, because I messed with it so much. Like, neopixels are actually pretty flexible, I think. If I had just realized that it might actually be the hardware, it would have saved me a lot of trouble. But now that you say it, it's just like, oh yeah, clearly the red's just not working. I agonized over that. Okay, what do I need to do? I need to make this gap longer. I'm gonna make it 16. So this is the middle. Do I want to make the middle longer? Let's make this longer too. 14. I was doing this yesterday too, this trial and error. What should you be seeing? When you start up, you should get yellow. I think it's actually 3 yellow blinks in 700 milliseconds or so. That's when safe mode is. And then you should see, if your code errors, you'll see 2 red blinks every 5 seconds. If your code finishes, you'll see 1 green blink every 5 seconds. And if it's running, you won't see anything, is what you should see. Oh, and I had a whole problem. I was trying to use GDB, and GDB was just like hating me. That's why I'm not even using the debugger. Like, I was in GDB, and when I did tar ext to the JLink, it would just infinitely like allocate memory and like cause my whole computer to be unhappy. Yeah, it should go bright white and no REPL. Okay, so this looks good still. So the neopixel's still happy with it. Let's see how we are in timing. Oh, that makes me so happy. We have to test the M0s though still, because the M0s are having the same problem. We might need to do the same cache. Right. One quicker way to do this is to actually change the neopixel pin. Maybe I'll do that. Oh, so the Salea code's happy with it now. You can see that there's these little pink boxes because the Salea confirmed it. Okay, look at that. So the zeros are, I know it's probably really tiny for you. The zeros are 34.15 duty cycle and a frequency of 813, so they're just a smidge fast. And then the ones are 813 as well, and 67. So they're both just a hair long. I think what I would add I think what I would add is just one or two more in the last empty. Like, I think that should be right. Make that 15. Could be a mechanical failure. Yeah, I mean, I would potentially see that with a microscope, right? If the bond wire for the red element died. I mean, I'm not nice to these boards because I've got so many of them. I have a USB microscope around here somewhere. I'll just probably order some more feather and fours. I know how to get more. I don't need to RMA or anything. I could just order them. Okay, let's try this timing. It would be interesting to look. I do know where it is, I think. What if I get my head real close? I could almost see them. That's why I have you folks to help me out. All right, so it is blinking. Let's just take another capture. Ooh, I caught one. I'm like slightly out of the view, aren't I? I'm holding it on the LED. Wow, look at that. 696. 796 at 33.6. 796 at 66.08. You should give away your old not totally dead M4 boards. Well, I think I've definitely had more feather M4s in the past. I think I have given them away. If you ever meet me in person, I usually do give them away. Like I've got like 4 M0 boards right here. Okay, if anybody wants this newer build, I think this is the timing that I'll go with. So let's call that done. And then, yeah, I'm in Seattle, and I'm going to be fully vaccinated soon. So we could have coffee or tea or something. Let's try the M0s. Let's see if it works. Feather M0 Express. I don't know what's on these, but they've been in the drawer so long that I assume that I don't care what's on them. Ah, maybe what we should do is actually, let's show the difference. So here's an old version. I have no idea what version of CircuitPython this is running. It is running CircuitPython because it's blinking like CircuitPython. But let's actually take a capture of the old LED behavior, since we have it on here. And I'll try not to blind myself figuring out which is the... where this endoscope is. I love it when I'm poking around a board and I accidentally like short it with the lead. Oh, did it crash? I don't see it. Logic. Maybe I did crash it. Okay, so here's the normal error, the current error behavior of CircuitPython. It's actually a lot quieter than I thought it would be, which is good, I guess. So there are large gaps here and then smaller gaps. So like, this is probably like, it's the green, yellow line number. So it is important to note that like after this, the LED is actually still on the whole time. So even though we're not transmitting a lot of stuff, which is good, the LED would be on for that period of time. So here, the current implementation here is actually coasting at like 978 kilohertz, 939, 922. Okay, so let's, that's a good comparison. Feather M0 Express, UF2, copy here. So we got safe, so the LED pattern is working. Oh, it's in safe mode. So this is what it does when it's in safe mode. My hand is too far away from my proximity sensor. Hard fault. Uh-oh. That's not good. Hard fault handler. Oh no. My GDB's not working. That's what I would use to debug it. I'm gonna hit it again and see if it... Oh no. Alright, well I've got... Oh, we're about out of time. Let's just see. I also have Metro M0. Metro M0 has a SWD connector. I can't push this. I'd love to send PRs out right before I go off for the weekend. Curse of live debugging demos. Yeah, I'm surprised it's crashing. I should delete. I have a lot of curious. It's not doing anything. Huh. Hello? So the M0 is not even safe moding. It's possible this is... Is a 0 or not? I mean, I'm sure I can recover it, but I don't think it's a prototype. Oh, you know, I copied the Feather M0 over, that's why. That'll do it. Okay, it did show up. So it's safe moded too. Interesting. It's safe moded. But it clearly safe moded from something on the drive. There's a bunch of stuff here. Why is it safe moding? What are the odds that my GDB is happy with me now? I don't think they're very good. So it is important that the blinking is working, like the timing of the blinking is working. Let me delete all of these prints because they do mess with the timing. Print F. Oh yeah, let's get rid of all this. I have like debug blinks as well. Let's clean all this up. Here we go. I think all this debugging stuff I had previously is no longer useful. And I'm bad about leaving it in. Nothing in there? Is it in neopixel? Yeah. Okay. Won't compile. Next, start raw ticks. Oops, I shouldn't have. I actually need that. These two I don't. Next, start raw ticks I do. And then where's this? Main.c 473. NP count. How is your GDB connected? I was trying to connect through the J-Link server. If it keeps crashing, I'll try to figure that out. Unreferenced skip count. Ports. Supervisor. Port. Skip count. Define reference to on/off. All debugging stuff. That was kind of useful. So what I had was a pin toggle every time that the real-time clock or real-time counter interrupt happened, I would toggle, which would give me an idea about whether it was working, whether the interrupts for that were actually working or not. Hey, it's no longer save moding because of the debugs. And it looks like it's working. I think this is worth just pushing. It is interesting. There's a TX pin here. And why is that going off? I thought the TX pin would be going off. Oh, we're printing new status color still. We have more prints. More prints to delete in status LEDs. new status color. Delete. And there's one more, I think. Should we show rebase? So I think this is correct. So what I'm gonna do is I'm gonna git add all of this current version of the code, and I'm gonna commit it as blah 2, and then get my PGP key. Don't show it, don't show it, don't show it. Copy. That's how my commits are verified. So I've committed this just as a bad commit name. So if I do git log, you'll see that I have simplify status LED, I have blah, debugging, blech, and then the actual like commit name. And so I think what I want to do is I want to make these 3 commits one commit that says fix for SAMD or something. So what I'm going to do is I'm going to actually rebase it on... Do I actually want to do that? Maybe not. Rebase. Can I do I? And then you can do head -3? 4? Yeah. So I can do pick. And instead of pick, I can do reword. And then these next 2 are fix-ups. So my goal is to have the individual one is the absolute newest builds from the 6.3x branch or the 7x branch. So they're gonna be a mix, actually, I think. So usually it's just from main, but the 6.3x branches should be pushed as well, I think. So you might want to compare the commit messages between the 2. Are all those prints just for debugging? Why not comment them out? Yes, they're just for debugging, and I delete them because they're rarely useful in the future. Fix timekeeping. RTC needed to wait for sync. Neopixel ID doesn't need disabled caches. Just needed timing adjustment for 120 megahertz clock speed. Okay. All right, so now if we look at our git log, we'll see that we have this simplify version and this one, and I apparently pushed it, which is a bummer. Because I think, like, this is the one that the PR was done on. If we kept debug prints but commented every other line would just end up having 1 in my code over time. Yeah. I use Vim for git work, not ST. Yeah, I do use Vim just for small stuff. I don't use it for like day-to-day programming. Just like when I only have a terminal, I'll use Vim. Okay, so the next one I want to do is I think I'm gonna Sublime Merge will have stuck with me a little bit longer. So I want to take a look at what the commits have. So here we can see that I accidentally pushed these other 2 things, so I don't want that. But what I want to do is I just want to make sure that, like, yeah, see here, in main, like, there's this stuff that I didn't comment out yet. So these are like extra blink stuff that are commented out that I do want to delete as well. So that's what that diff is really nice for. It should be right here. So let's delete that. And this won't show these immediately. Here's an extra line here for skip REPL, and like, there's no need to have somebody review that, so I'd rather just delete it. So deleted, deleted, deleted. Oh yeah, I forgot this. If time to next change is greater than 0, then do it. But you actually always want to do it, because even if time to next change is 0, you want to make sure that you continue. If you don't set interrupt after ticks, you'll end up sleeping too long. I think that must have been the M0 problem. Neopixel pin doesn't need to be protected from reset anymore. Drive strength. Oh, I should undo that. I don't need to change that. So that's in digital IO. I'm so glad that I brought this up on the stream. I was like so disheartened with why red wasn't working, only to have somebody be like, it could just be broken, which is great. Okay, so that is changed back. These timings we do want to change, and I had to add this extra timing. And then I deleted that. And here's another print in PWM out, which we don't want either. So this is when I do use rebase, because like I put a debug print in a place that like I really don't mean to change, right? I was using PWM out just to verify that the clocks were set up correctly. Like I was going to think, how crazy would it be if the SAMD 51s are all clocked at 48 megahertz for ages? I added this woken up stuff. I think I'll leave that in. Feather NRF turning on the neopixel. That was just a mistake. And then here's a commented out print that I'll delete as well in status LEDs. Where is that? Here it is. Okie dokie. So now what I'm going to do, because I basically want, these are all changes that I want to make on this commit. What you can do is if we do git status, and then git add all the things. So now git status will see that they're staged. But now I want to do git commit -- amend. And so that will add these changes to that existing one. And so if we look back here, in merge, we can now see that like there's fewer files, and we just have the changes that we care about. So yeah, so that is what we want. So we're gonna git push tinnew, and we're gonna force release because we're gonna go back in time, or we're gonna go to a different commit because I accidentally pushed the debug commits there. I could have kept them locally, so they don't show up on the PR, but okay. So now if you go to the pull request, we have this simplify status LED to save power. Like the reason not to get rid of that first commit is because like Nerodoc's comment here is on that commit. So it's good to just, whatever people have commented on, I try to leave. Let's go back here. So now we can see that I pushed that commit again because I was force pushing stuff, and now it's the build is running on the fixed SAMD commit. So that's super exciting. Thank you. I think it was yeah, Christian. Thank you for pointing out that that could be my problem. Yeah, and I realized that this is just a little bit funny. Okay, so let's wrap up. I forgot to turn the light on. It's a little front lighty in here. See, it looks better, right, with the overhead light on as well, even though I have the front light too. Oh, and the cat is He's in his third option, which you can't see. Unless I move that out of the way. I'm getting ready to end. That's how you know. So thank you everyone for joining me on this deep dive. Next week will be on Friday as well. I'm happy to see that the LED stuff, it looks good. Please test that commit or that PR. Let me know if it doesn't work on any other platforms. It's possible. I am not that thorough a tester, honestly. Patrick, you should definitely check out the earlier bits. I showed some of my broadband map stuff off, which I think you might be interested in. And talked about the fact that the local broadband thing here passed as well, which is exciting. Or it was signed by the governor. Let's see. If you want to support me, support Adafruit by going to adafruit.com and purchasing any of the hardware that you've seen. Thanks again for everyone to hang out. Please try CircuitPython if you have not. Some people haven't. If you want to hang out with us outside of this stream, you're welcome to join the Adafruit Discord server by going to the URL adafru.it/discord. Yeah, check that out. As always, thank you so much for hanging out. I will see you next week on Friday. And enjoy your weekend. And if you have the opportunity to get vaccinated for COVID-19, please do so. I'm going to get my second shot on Monday, and I'll let you know next week how that second shot goes. It should be fine, and I'm excited about it. But yeah, I'd like to be open about it. I would encourage everyone to get it when you can. So I'll kick over to Cat Cam and wake the cat up and give him some pets, and then we'll be out of here for the weekend. So thank you all, and we'll see you next week. Sweet, do you want to say goodbye to people? Have a great weekend, everyone.